Hello and welcome back to part 5 of Make Your Own Emulator. In this episode we will code another couple of instructions and we will probably hit the key check part. So I already wrote that as the uh, assignment will be to make a keyboard reader into the frame, but I will explain it a bit more once we hit the actual point in which I will explain the assignment. Um, so let's see which code is the next code, which crashes the program. And it is FE33, which is FX33. So we will skip to F. Surprise, it doesn't exist yet. We will add a multicase. Statement which will switch on the operation code and the last byte, and we will add the default case and case OX33, which is store a decimal value. So I will copy it. No, that's a big one. I won't copy that. FX33 store a binary coded decimal value. Vx in y plus 1 and y plus 2. So first of all we we will grab the byte from Vx. So we will switch the operation code and the seconds nibble. And now we need to place the hundreds in y. Memory. I'll first create the variables hundreds equals 0, int tens equals 1, int ones equals 0, and then memory y equals hundreds, memory y plus 1 equals tens, and we will need to cast that to chars. And the last one is memory y plus 2, which is the ones. So now for the actual calculation, we will do some use of the modulus sign and with dividing. So let's say we want to store the decimal value 156. So this should become 1, 5, 6. Now we can do sneaky and just cast it to a string and explode it for each character or so, but I'm not going to be that sneaky. So too bad for you. I will though take a little peek on the code, guys. Thanks. Yes, I'm doing this on a second monitor. I will peek. There we go. Oh god, it's a big value, of course it is, and it's a big operation. So to calculate the hundreds, we will need to get the remainder after the division of 100, so we'll divide x or by 100 and take the remainder, which is what the modulus does, and subtract that from x, and now this value will be 100, but it should be 1, so we'll divide it by 100. Now for the tens, we will actually remove the hundreds from the case. Which we should multiply by 100 again. And this will leave us with a bit of less work, because we will actually do the same x over 10 divided by 10, and then we will do or subtract the tens times 10 times, thanks, and well, the remainder is the ones, which equals x at that point. So I'm actually going to fill in x to save just a bit of memory, and as we will give the explanation, storing decimal or binary coded decimal at decimal x v x opcode as, and we'll do it in array representation plus hundreds plus tens plus 1 x. V opcode and x ff, else it will be the same as ones. So let's see if the value returns correctly. And I believe it's, whoa! Oh, how about we cast or shift it back by 8 bits? Because else we get a bit of a trouble. Wait, I actually broke my own pattern here. Value. Bad Jai, bad. Keep your patterns. Keep your nasty patterns. So this will be x. No shifty calculations on that one. And this one we do. So it's unused, they say. Value. There we go. And now we'll run it again. And it's storing value. I'm a bitch about the format, but and it will store v0 equals int. There we go. v14, which equals 0 as 0, 0, 0. Now I want to test it, so I will overwrite the value for this run. So, and as you can see, it works. So we will go to the next bit of code and we will advance the program counter. So there we go. Unsupported opcode. How about I add a break here? Break. Alright, F265. This means F265. Okay. That case is OXO65, which is FX65, fills V0 to Vx with values from Y. So I'm kinda worried cause let me check the tag reference, cause I'm kinda expecting the memory address of this one to increase as we write the values. The interpreter takes decimal value. No, doesn't do, so this should go alright. So int x equals the opcode and OXFOO shifted to the right by 8. We will v4 int y equals 0, y smaller than x, y plus plus, vy equals 0. And we will print the output, setting vo and to, is it up to including? I actually have no idea. Uh, oh, memory y plus y. There we go. Memory to memory. Oh. Vx to the values of y memory integer to hex string y to upper we can't be super precise about this one because that would create a bunch of coding actually. Here we go. Upper. There. And we will check to F2. There we go. Alright. This probably should be correct. I'm a bit considering if it should be this or just this. I'm guessing for smaller than, because it's 2 and not up to and including. But yeah. I don't know. There is a note that the original interpreter would increase the memory address by x plus 1. So let us do that. Plus is equals x plus 1, as noted by note 4. I will check in the other description if that also mentions it. 65. Well, that one doesn't note it, so I will just leave it out because I'm not trusting it. Alright, next code. Adding the break and the PC plus equals 2. There we go. Now we got 29. It's going fast. OX29, which is sets y to the location of the sprite for the character vx, which reference to the font set. So we have our font set at the location OX50. Yeah. So we will x equal int char character equals vx, which will be a byte, and the font set is 5 bytes long, so for each thing they will have y equals char memory, or no, OX50 plus character times 5, and we'll cast that to a char. So if it's the value 0, it should be just at the start, and then it will increment per digit by 5. We'll print that to the console. Setting y to character offset vx offset to integer to hex string y to uppercase PC plus equals 2 break, and we'll of course this should be an int because it's a bloody already running. There we go. Setting v2 equals 0 to offset x is 50. These are probably the big numbers. Yeah, those are the two big numbers from the score. And as a matter of shame, we will not be getting to the key part yet, but I will give it as homework. And I'm not sure if I can peek in it. No, I won't peek in it. I will explain it. The chip 8 has a keyboard which has 16 characters, and we aren't known to having 16 characters. So I will check if I can find a keywords image. Yeah. This is the little keypad is the input, and in my version I've mapped it to the same in a layout from 1, 2, 3, 4 keys and then downward. So up to and including Z, X, C, V. And in the frame you will implement a key listener, and that will basically be the entire coding. But that's not it. As you can peek here, I got a key or a function set key buffer, which is actually copying the keys from the frame, as the keys should not be inserted asynchronously, as we don't want the key state to change halfway during the program. We want it to be nice and regulated during the chip processing. So only when I will peek a bit here. So whenever this one is also wrong. I want it to be here. If you want to send the keys before the run or after run, doesn't really matter. It's just a delay of 1 frame. I prefer to have it before it, but you will have to write it out and make sure that all characters are being sent into correct index, as we will be handling the image as this will be index 0. I believe this is 0 or so. I want to have a little peeky peek, frame. No, I've used the actual values. The 0 equals 0, 1, 2, 3, 4, 5, etc. And I've mapped that to my keyboard. I'll give as a hint that you can use the character values of actually the character values, not a string but a character, to get the value of that, or the integer value of that character. Use it wisely and create something amazing. And I will see you back on Sunday.